Hi guys, let's start. SHM in rolling motion. SHM in rolling motion. Suppose there is a body on a rough surface. There is a body on rough surface. Body may be a disc, cylinder or a sphere, but a spring is connected to this point. Constant of the spring is K. Mass of the body is m. Moment of inertia above center of mass is m0. And radius of the body is r. Body moves such that about point P, body have pure rolling. Body have pure rolling motion. Pure rolling motion. Then find time period of the motion. Then we have to find time period of the motion. So in this case, step 1 is rotate body a little bit by an angle theta that is very small. That is very small. And calculate torque and calculate restoring torque. And step 2, comparing with the standard condition for angular SHM, we can find time period. So in this case, this is the initial position of the center. Now center rotated by some angle here theta, so that now a spring becomes compressed by some length. Here this distance is r, this distance is also r because angle is small. So this length is r d theta, and compressional force on the spring is k r d theta. So force applied by a spring on the body is k r d theta. So if this is a point P, instantaneous axis of rotation point, so torque about instantaneous axis of rotational point is I about instantaneous axis of rotation into alpha. And what is torque? Torque is minus k r d theta multiply r. This is the IAOR alpha. So what is alpha? Alpha is k r square over I. I is what? About instantaneous axis of rotation multiply minus d theta or theta. Here angle is theta, r theta. Angle is r theta. So comparing, omega square comes out to be kr square divided by IAOR. What is IAOR? IAOR is nothing but I of the center of mass plus mr square from parallel axis theorem. So what is omega? Omega is under root kr square divided by I center of mass plus mr square. So time period comes out to be 2 pi over omega, and that is 2 pi over I center of mass plus mr square divided by kr square. So this is our required result here. This is our required result. Now in the next part, suppose a spring is connected with this body by at a distance x above the center. Constant is K. Surface are sufficiently rough so that there is no slipping of the body. This distance is R. So same process we have to apply. Rotate it by some angle theta so that a spring is compressed, and now a spring apply a force of kr theta, where this compression length is r theta. K here r comes out to be, here a spring force comes out to be kr plus x into theta. Here this distance total is x plus r. This distance is x plus r. So this distance is x plus r into theta. So torque about instantaneous axis of rotation. Is minus instantaneous of rotation is IAOR into alpha, and that is minus kr plus x into theta into r plus x. So alpha is what? Alpha is minus k r plus x square over IAOR into alpha. So comparing with the standard condition for angular SHM, omega square comes out to be kr plus x whole square divided by I of IAOR, instantaneous axis of rotation. What is IAOR? Instantaneous of rotation is what? I center of mass plus mr square. So omega square equals to kr plus x square, and that equals to I center of mass plus mr square. And what is the time periods? Therefore time period comes out to be 2 pi over omega, and that is 2 pi over I center of mass plus mr square divided by k into r plus x ka whole square. So this is our required result. Suppose in an example, body is at an inclined plane and a spring is connected like this, and body is in pure rolling during rotation during SHM. So what will be the time period in this case? Mass of the body is m, center of mass, moment of inertia is I naught, radius is r. Same process we can apply, and also the time period will be same, 2 pi under root I center of mass plus mr square over K into R square. There is no effect of constant force. There is no effect of constant forces.